Lesson 856, Graphs of Stories, Creating Graphs of Functions. In this lesson, we'll draw the graph of a function that represents a real-world situation and understand that graphs can appear differently based on the variables chosen. Okay, friends, I really suggest you go to the activity on Desmos today for lesson 6. It's on a playground, and there's kids doing things on the playground that you're asked to graph. I think it's a lot of fun. So that's what our lesson's about today, is just really understanding a little better the stories that the different graphs tell. It's just a continuation of things that we've been talking about already. We're on page 19, and our learning goals include drawing the graph of a function that represents a real-world situation. So draw a graph of a function that represents a real-world situation. Draw a graph of a function that represents a real-world situation. And explain that graphs can appear different. Or I should say differently. Depending on the variables that are used. And this came out more in the actual activity when we looked at different things plotted over time for the same video. All right, but in our notes today, we're going to just look at how we can capture the details of a real-life scenario with a graph. So I'm breaking out all the highlighters for this one because we're going to focus on each part of this graph that represents this scenario. Let's read through. Elena starts to walk home from school. She turns around and goes back to school because she left something in her locker. At school, she runs into a friend who invites her to the library to do homework. She goes to the library, she reads a book, and then heads home to do her chores. So this is the scenario we're going to try to tell the story of using this graph. The graph is already made for you for the most part, but there's a few things that we need to fill in. We're going to start with labeling both axes so the graph accurately represents this situation. So let's talk about what our two labels can be. Let's start with this x-axis right here. So this is going to represent 0 for both of the quantities that we talk about. Now, all of our scenarios today dealt with time. So this is going to measure time. Time is almost always the independent variable. But it's important that we use a measurement of time that is realistic for our scenario. Are we talking about seconds? Are we talking about minutes? Are we talking about hours? And since we're talking about her, after school, she does all these things, she comes home, I think I'm going to go in minutes, but I'm going to have a lot of them. I think this is going to take her like 90 minutes. I'm going to go in little intervals of 30. And this doesn't have to be super precise, but I just want to have in mind what's happening in our scenario, starting at right after school, and then the clock starts until she gets home, an hour and a half later, or 90 minutes later. So that's one axis, the time in minutes. And this is about Elena at school and going home. And I have to pay attention to what's happening in the graph. I'm going to look at the very beginning of the graph. And I notice that at 0 minutes, she's not at 0 for this, whatever this is. And I'm thinking this is going to be some kind of distance. I'm going to measure mine in miles since she's, going from school to home. Measure mine in miles, but I can't just say distance. I can, but it won't be very precise. Is this the distance from the library? Is it the distance from home? Or is it the distance from school? Well, if I have a distance that seems, pretty far away from 0, I'm going to say this is my distance from home. This point up here tells me I'm not at home. If I was at home, the distance from home would be 0. But here I am at school, and the distance from home, I'm going to say, I'm just making this up. We're going to go in miles here. I'm going to say this is 2 miles. That's like 1 mile, just to give myself some context. Okay, so I've done it. I've labeled both axes so my graph accurately represents my situation. This covers a course of about 90 minutes, and we're talking about 2 miles distance from home. And for the next thing, we're going to label each segment, 1, 2, 3, 4, 5, 6 different segments with what's happening in the story during that time. So for example, in the first segment, she's walking home from school. So just so we can match things up, I'm going to highlight what's happening in the story and label the corresponding part of the graph that shows that. So here it's 0 minutes. She's 2 miles from home. And so I'm going to say walking home from school. Okay, so that's the first part. And then it looks like it changes from her, sorry about that, getting, having the distance from home decrease, and then her distance from home is increasing again. So let's go back to our story and see what happens. So it looks like at this point, she turns around and goes back to school because she left something in her locker. I'm going to say back to school. She goes back to school here, and now she's the same distance as when she started. She left school, now she's back. She's still 2 miles away from home. All right, then there's this little flat part. It looks like she's not moving at all. I wonder what's happening. It says, at school, she runs into a friend. Oh, I think I know what's happening. She's talking. Invites her to the library to do homework. Okay. So this is the part where she talks to a friend. All right. And then her distance from home changes again. It starts to decrease. She starts getting closer and closer to home. She doesn't get all the way there. It looks like she goes from about 2 miles from home to a little over 1 mile from home. And it looks like this is what's happening. She's going to the library. I had to dig deep for an orange pen. So this is the part where she's walking to the library. And as she's walking, the distance from home is decreasing. And there's this real flat part here where she's not getting any closer to home and she's not getting any farther away from home. Her distance from home is remaining unchanged. Let's look at what's happening there. So she's at the library and it looks like she sat down to read a book. I know you're amazed with all of my colors. Here's where she reads a book. And then her distance from home decreases again until she is 0 miles from home after 90 minutes. What color will she use? Haha, purple. I do have one last color. She heads home to do her chores. That's what happens in this last segment. She's walking home. Oops. And then her distance from home is 0, meaning she is at home doing her chores like a good young lady. All right. So this is telling the story of what's going on in our little scenario. I do want to make mention of a couple of things that are important to pay attention to. First of all, pay attention to precise labels. In the activity today, we had a short little 15-second video, and we looked at it with measuring one variable, the distance from some kid's waist to the ground, and then looked at the same video and how the graph would change if we were looking at the distance of that child from the edge of the screen. And they were very different looking graphs. So we have to have precise labels. Don't assume what distance means. So if I say distance, it might be better to say distance from the ground. Which is different than saying distance from home. Or distance from the swing, or any other thing. Similarly, let's see what else we want to say. Make sure you understand what the units represent. It has to do with precise labeling. Does 1 mean 1 minute or 1 hour? Or 1 second? So just make sure you understand what you mean when you say 1. So just focus really on the labels and what should be happening over time based on that label, because graphs can look really different depending on what variables you use. Right, so just on our continuing mission to tell a story of a real life scenario with a graph.